Hello students, welcome to Yupp Master. This is 11th class IIT Live. I am Radha Krishna, mathematics teacher. Today we are going to continue our topic sequences and series. First we will solve some problems on AM, GM, HM, and then we will discuss about a wonderful method, that is telescoping series. Alright, let us solve few problems on arithmetic means, geometric means and harmonic means. If 2n minus 1 arithmetic means, 2n minus 1 geometric means and 2n minus 1 harmonic means are inserted between two numbers, then their nth means are in which progression? Let us consider the two numbers as a and b. Between a and b, 2n minus 1 AMs and 2n minus 1 GMs, 2n minus 1 HMs are inserted. Let the arithmetic means be denoted by A1, A2, A3 and so on. So, first term is A, A1, A2, A3 and so on, A, 2n minus 1, B are in AP. Alright. These middle numbers A1 to An minus 1, A to n minus 1 are arithmetic means between A and B. And between the same numbers, 2n minus 1 geometric means are inserted. Let us denote them by G1, G2, G3 and so on. Then G1, G2, G3 and so on, G2n minus 1 comma B are in GP. Alright. Similarly, 2n minus 1 harmonic means are inserted between A and B. Let us denote them by H1, H2, H3 and so on. A, H1, H2, H3 and so on. H, 2n minus 1 comma B are in HP. Alright. Now, their nth means, that means nth arithmetic mean, nth geometric mean and nth harmonic mean are in which progression? That is the question. What is the nth arithmetic mean? It is An. Nth geometric mean is Gn. Nth harmonic mean is Hn. You will think that you need to find An, Gn, Hn by our formula, but no need to find. We have a property of AP. Sum of the terms equidistant from left and right will be same. That means first term plus from left first term plus first term from right is A plus B, that is equal to A1 plus An 2n minus 1, that is equal to A2 plus A2n minus 2 and so on. Is it not? This is the property of AP. Now, you can observe that An is exactly in the middle. Before An there are n minus 1 means, after An there are n minus 1 means. So, if you pair like this A and B, A1 and A2 n minus 1 and so on, An will be left alone. It has no partner to pair. So, what we do? How to apply this property for An? We have to take An two times. So, An plus An will be equal to A plus B. That means 2An is equal to A plus B. Or we can write An is equal to A plus B by 2. Alright. Similarly, in GP what is the property? Product of the terms equidistant from left and right will be same. That means A into B will be same as G1 into Gn 2n minus 1 is same as G2 into G2n minus 2 and so on. Here also Gn will be left alone, you cannot pair it. So, we have to take Gn two times. So, Gn into Gn, that is Gn square will be equal to A1 into A into B, AB. Alright. Similarly, in harmonic progression, this Hn will be, here you observe that An is single arithmetic mean between A and B. Okay. The middle number is the arithmetic mean of A and B, and this middle number Gn is the geometric mean of A and B. Gn will be equal to plus or minus root AB. Similarly, this Hn will be the harmonic mean of A and B, single harmonic mean of A and B, that is Hn is equal to 2AB by A plus B. All of you know this formula. Then these three are in which progression? That is the question. Hn is equal to 2 into AB can be written as Gn square and A plus B can be written as 2AN. 2 cancels. We will get Gn square is equal to AN into Hn. So, AN, Gn, Hn are in geometric progression. If B square is equal to AC, we know that ABC are in GP. So, if Gn square is equal to AN into Hn, AN, Gn, Hn are in geometric progression. So, the correct answer is second option. Alright, let us move to next question. If XYZ is equal to 55 or 343 by 55, according as A, X, Y, Z are in AP or HP. What does it mean? If A, X, Y, Z are, comma B are in AP, then the product X, Y, Z is 55. If the same numbers are in HP, the product is equal to 343 by 55. Then where A and B are positive integers, then find the value of A plus B, that is the question. Now, when they are in arithmetic progression, let us denote the values of x, y, z as x1, y1, z1. When they are in HP, denote the values of x, y, z as x2, y2, z2. Then A, x1, y1, z1, B are in AP. If A, x1, y1, z1, comma B are in AP, then what is the value of the product x1, y1, z1? It is 55. Alright. If they are in HP, when they are in HP, we denote the values of x, y, z as x2, y2, z2. A, x2, y2, z2, B are in HP. Then the product x2, y2, z2 will be equal to 343 by 55. Okay. Now here x1, y1, z1 are 3 arithmetic means between A and B, and x2, y2, z2 are 3 harmonic means between A and B. When equal number of arithmetic means and harmonic means are inserted between same numbers A and B, then we have a property. What is that property? Product of kth arithmetic mean from left and kth harmonic mean from right will be equal to product AB. That means x1 into z2 is AB, y1 into y2 is AB, and z1 into x2 is AB. Alright, x1 into z2 is AB, y1 into y2 is AB, and also z1 into x2 is also AB. Now, if you multiply x1, y1, z1 with x2, y2, z2, this is nothing but product of this, this and this. So, what is its value? AB into AB into AB, AB whole cube. Its value is given as this product, this into this, 55 into, this is 55, this is 343 by 55. 55 cancels. So, AB whole cube is 343. Can you write 343 as a perfect cube? Yes, we can write it as 7 cube. So what is the value of AB? The product AB must be equal to 7. Seven is a prime number. It can be factorized in two ways, either 1 into 7 or 7 into 1. We know that A and B are positive integers. So what must be the values of A and B? If A is 1, B is 7. If A is 7, B is 1. So A and B are one and 7 or 7 and 1. What do you want? Sum A plus B. So in both the cases, sum A plus B is 8. So this is our answer. Alright, let us proceed to the next question. If H1, H2, H3 and so on Hn are n harmonic means between A and B, then H1 plus A by H1 minus A plus Hn plus B by Hn minus B equals, 4 options are there, n, n by 2, 2n, 3n. If H1, H2, H3 and so on Hn are at harmonic means inserted between A and B, then A, H1, H2, H3 and so on Hn comma B are in HP. Alright. If they are in HP, we have a formula for kth harmonic mean. The formula for HK, kth harmonic mean from left is n plus 1 into AB by n minus k plus 1 into B plus Ka. Alright. You want H1 and Hn. So H1 is equal to, take k is equal to 1, it will be n plus 1 into AB by NB plus A, and Hn will be equal to, H1 is first harmonic mean from left, Hn is first harmonic mean from right. So we can get Hn by just interchanging A and B. N plus 1 into AB, by interchanging A and B, numerator remains same, denominator becomes Na plus B. Alright. Now we want H1 plus A by H1 minus A. Let us calculate. H1, for calculating H1 plus A by H1 minus A, you divide by A first. H1 by A will be equal to n plus 1 into B upon NB plus A. Alright. Now apply component and dividendo. All of you are aware of component and dividendo. So applying component and dividendo, numerator plus denominator H1 plus A by numerator minus denominator will be equal to numerator plus denominator n plus 1 into B plus NB plus A by numerator minus denominator what is it? In numerator, if you take B common from these two, you will get 2n plus 1 into B plus A by, in denominator NB cancels, we will get B 1 into B, B minus A. Now you don't need to calculate Hn by B again, no need of doing all these calculations. Directly interchange A and B, you will get it. So directly I will write Hn plus B by Hn minus B, is it not, is equal to interchange A and B, n plus 1 into A plus B by A minus B. Now we want to add these two. this denominator is b minus a, this denominator is a minus b. So let us write this denominator as b minus a, taking minus sign in the numerator. Minus of n plus 1 into a plus b by b minus a. Now you add h1 plus a by h1 minus a plus hn plus b by hn minus b equals, denominator is common, so I will write b minus a as common denominator. Numerators are by adding, sorry, here you will get 2n plus 1. Here also 2n plus 1, here also 2n plus 1, alright. Now if you add these two, what you will get? 2n plus 1 will be common in the first term, in the numerator. 2n plus 1 into b minus a, alright. Next remaining is plus a minus b. You can write plus a minus b as minus of b minus a, because denominator is b minus a. So dividing by b minus a, you will get 2n plus 1 minus 1, so answer is 2n, alright. Let us proceed to the next question. Now we are going to discuss telescoping series. What is a telescoping series? You remember one general point. You know the sum of n terms of AP, sum of n terms of GP, sum of n terms of AGP. We have derived. Other than these three, if you want to find the sum of any series, this is the only method. Telescoping series is the only method for finding any other series. Okay, let us discuss what it is. This method is called method of differences. Consider a series Sn is equal to T1 plus T2 plus T3 and so on Tn. T1 is first term, T2 is second term and so on in the usual notation. If we can express the rth term, general term, in the form of ur minus 1. What is ur minus 1? Tr will be some expression in r. You should write it as difference of two terms such that first term is something in r. In that first term, if you replace r by r minus 1, you should be getting second term. Okay, if you write it as ur minus 1, then what will be the sum of the series? T1, if you want T1, put r is equal to 1, you will get u1 minus u0. Second term T2 becomes, Tr is ur minus 1, putting r is equal to 2, second term is u2 minus u1, putting r is equal to 3, u3 minus u2 and so on. Finally putting r is equal to n, Tn will be un minus 1. Now this kind of series is called telescoping series. In this telescoping series, here if you observe, u1 cancels, plus u2 and minus u2, these two will cancel, u3 will cancel for second part of the next term. In this way, in the final term, un minus 1 will cancel. So after writing the telescoping series, then some part of the first term and some part of the last term will be remaining, all remaining terms will cancel out. Then the sum will be un plus un minus u0, un minus u0. We are expressing every term as a difference so that all middle terms are cancelled. That is why it is also known as method of differences. Alright. Sometimes you can write Tr as ur minus 1 minus ur. Then you will get first term as u0 minus u1, second term as u1 minus u2, third term u2 minus u3, last term un minus 1 minus un. In that case, after cancellation of all terms, the answer will be u0 minus un. Alright. Now you can understand it better while solving the problems. So I am going to solve one question on telescoping series. Evaluate the sum 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on 1 by n into n plus 1. We have to express every term as a difference so that all middle terms are cancelled. That is the method of differences. If you observe the denominator, every denominator has two factors and the difference between the factors of denominator is 1 in any term. Here also n plus 1 minus n 1. So, let us write the numerator as difference of the factors of denominator everywhere in every term. If you denote the sum of the series by Sn, Sn is equal to, first numerator I will write it as 2 minus 1 by 1 into 2. Second numerator I will write it as 3 minus 2 by 2 into 3. Third numerator I will write 4 minus 3 by 4 into 3 and so on. Last numerator n plus 1 minus n. Upon n into n plus 1, alright. Now, if you separate the denominators, 2 by 1 into 2 is 1, minus 1 by 1 into 2 is 1 by 2, plus 3 by 2 into 3 is 1 by 2, 2 by 2 into 3 is 1 by 3. Similarly, next term 1 by 3 minus 1 by 4 and so on. Last term will be n plus 1 by n into n plus 1 is 1 by n minus n by n into n plus 1 is 1 by n plus 1. Now, this can be called as telescoping series. Every term has been expressed as a difference of two terms. Then you see 1 by 2 cancels, minus 1 by 2 plus 1 by 2, minus 1 by 3 plus 1 by 3, minus 1 by 4 and next first part of the next term will be 1 by 4. So, like that, which term will be cancelled in the last term? First part will cancel out 1 by n, because if you observe here 1 by 3 is cancelled first, after that second part is getting cancelled. So, finally 1 is remaining here, minus 1 by n plus 1 is remaining there. So, sum is 1 minus 1 by n plus 1, taking LCM, n plus 1 is LCM, you will get n plus 1 into 1, n plus 1 minus 1, that is n. This is our answer. But we have not used the formula TR is equal to UR minus 1. You will think, but we have used. If nth term is this, what is the rth term TR? 1 by R into R plus 1, alright, rth term. Now, you can write numerator 1 as R plus 1 minus R by R into R plus 1. If you separate the denominator, you will get 1 by R minus 1 by R plus 1. If this is UR minus 1. It is in the form of UR minus 1 minus UR. That is what we have done. Putting R is equal to 1, we get this. Putting R is equal to 2, you get this. Putting R is equal to 3, you get this, and so on. Okay. So, no need to write this. If you get the idea, you can directly do like this. Okay. So, answer is n by n plus 1. Let us take up the next question. Evaluate 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 and so on till n terms. In the previous question, the difference between the factors of denominator is 1, but here it is 2. Okay. If we have 2 in numerator, we can write 2 as difference of these two everywhere. Is it not? So, what we do is, we will multiply all numerators by 2 and divide outside by 2, then we will write the 2 as difference of these two. But you can do like this only when the factors of denominator are in arithmetic progression. See 1, 3, first factors are 1, 3, 5 and so on, it is AP with comma difference 2. Second factors 3, 5, 7 and so on, that is also AP with same common difference 2, and difference between the first and second factors is also equal to common difference 2. Now, nth term is not given, so first we should find nth term. Tn is equal to, in denominator we will have two factors. The first factor will be nth term of this AP 1, 3, 5 and so on. In the AP 1, 3, 5 and so on, what is the nth term? Common difference is 2. So, formula for nth term is a plus n minus 1 into d, that is 1 plus n minus 1 into 2. What is it? 2n minus 1. So, first factor of the nth term is 2n minus 1. How do you get the second factor now? First factor plus 2 will be the second factor. So, this plus 2 will be 2n plus 1. This is second nth term. Now, let us write the series. Take the sum as Sn. Sn is equal to 1 by 1 into 3 plus 2 by 3 into 5 plus 1 by 3 into 5 plus 1 by 5 into 7 and so on. Last nth term is 1 by 2n minus 1 into 2n plus 1. Alright. Now, we want to write every numerator as the difference of the factors of denominator. What is the difference? 2. So, we should multiply by 2 and divide by 2. Divide by 2 outside, multiply by 2. Okay. Now, you write this 2 as difference of factors of denominator, half into, this 2 is 3 minus 1 by 1 into 3. This 2 is 5 minus 3 by 3 into 5. Next 7 minus 5 by 5 into 7 and so on. Here 2n plus 1 minus of 2n minus 1 by 2n minus 1 into 2n plus 1. Alright. Now, separate the denominator. 1 by 2 into 3 by 1 into 3 is 1 minus 1 by 3 first term. Second term 5 by 3 into 5 is 1 by 3 minus 3 by 3 into 5 is 1 by 5. Next term will be 1 by 5 minus 1 by 7 and so on. Last term 2n plus 1 by 2n minus 1 into 2n plus 1 is 1 by 2n minus 1 minus this by this is 1 by 2n plus 1. Which is a telescoping series. 1 by 3 cancels, 1 by 5 cancels, 1 by 7 cancels and so on. In the last term, first part will cancel out. So, what is the sum? Half into. First term is 1 minus 1 by 2n plus 1. Alright. Take LCM and simplify. Half into 2n plus 1 is LCM. You will get numerator as 2n plus 1 into 1, 2n plus 1 minus 1. So, what is the final answer? N upon 2n plus 1. Alright. Let us proceed to next question. Find the sum 1 by 1 into 4 into 7, 1 by plus 1 by 4 into 7 into 10 plus 1 by 7 into 10 into 13 and so on till infinity, not till n terms. And also every denominator has 3 factors. Of course, the factors are in arithmetic progression. That is the common link between the previous question and this question. Factors are in AP. If you take first factors 1, 4, 7 and so on, they are in AP with common difference 3. Second factors are also in AP with common difference 3. Similarly, third factors, and difference between the consecutive factors is 3. Then first we need to find sum of the n terms. We cannot directly get the sum up to infinity. First we need to find the sum of the n terms. Then taking n as infinity, we will see what we will get. For getting the sum of n terms, we need to find nth term first. Tn is equal to 1 by, if you observe the first factors 1, 4, 7 and so on, they are in AP now. What is the nth term of the first factors? In this AP, nth term is a plus n minus 1 into d, that a is 1 plus n minus 1 into common difference is 3. How much you will get? 3n minus 2. First factor of the nth term in the denominator is 3n minus 2. Now, second factor is first factor plus 3, third factor is second factor plus 3. So, second factor will be this plus 3, 3n plus 1, third factor is 3n plus 1 plus 3, 3n plus 4. So, this is the nth term. Now, how to express this as a telescoping series? How to express every term as a difference? That is the question. In this question, you write the numerator as last factor minus first factor. Last factor minus first factor is how much? 7 minus 1, 6. Here 10 minus 4, 6. 13 minus 7, 6. In the nth term also, last factor minus first factor is 6. Okay. There can be any number of factors in denominator, but factors must be in AP. There can be 4 factors or 5 factors, but the method is same. Write the numerator as last factor minus first factor. But last factor minus first factor is 6. We don't have 6 in numerator. So, we divide and multiply by 6 first. First you write Sn 1 by 1 into 4 into 7 plus 1 by 4 into 7 into 10 plus 1 by 7 into 10 into 13 and so on. Nth term 1 by 3n minus 1, 3n minus 2 into 3n plus 1 into 3n plus 4. Alright. We should multiply by 6 and divide by 6. Alright. And outside write 1 by 6. Then you will get into 6 here. We will write that 6 as 7 minus 1, last factor minus first factor, by 1 into 4 into 7. Here numerator will be 6. We will write it as 10 minus 4 by 4 into 7 into 10. Here this 6 can be written as 13 minus 7 by 7 into 10 into 13 and so on. Last term we get 6 here. We can write that 6 as 3n plus 4 minus of 3n minus 2. Alright. 3n plus 4 minus of 3n minus 2 upon 3n minus 2 into 3n plus 1 into 3n plus 4. Bracket close. Now, if you separate the denominator, 1 by 6 into 7 by 1 into 4 into 7 is 1 by 1 into 4 minus 1 by 1 into 4 into 7, but we can write it as 4 into 7 plus next term 10 by 4 into 7 into 10 is 1 by 4 into 7 minus 1 by 7 into 10. Next 1 by 7 into 10 minus 1 by 10 into 13 and so on. Last term, if you separate the denominator, 3n plus 4 cancels first, you will get 1 by 3n minus 2 into 3n plus 1 minus 1 by 3n plus 1 into 3n plus 4. Alright. Now, it is a telescoping series. 1 by 4 into n, 1 by 4 into 7 cancels, 1 by 7 into 10 cancels, 1 by 10 into 13 cancels. In the last term, first part will cancel. So, what are you getting? 1 by 6 into Sn is equal to 1 by 6 into 1 by 1 into 4 is 1 by 4. Last term is remaining now 1 by 3n plus 1 into 3n plus 4. This is sum up to n terms, but what is the asked question? We want sum up to infinity. Now, if n is approaching infinity, we write the sum as s infinity, sum up to infinity. When n is infinite, approaching infinity, 3 into n will also be approaching infinity. 3n is also infinity. Infinity means a large number. Okay. So, 3n tends to infinity and 3n plus 1 is also infinity. Infinity plus any finite number is infinity. Infinity minus any finite number is infinity. Infinity into infinity is infinity. Is it not? So, 3n plus 1 tends to infinity. Similarly, 3n plus 4 also will be approaching infinity. Infinity into infinity is again infinity. Then 1 by infinity is a very small number close to 0, which is negligible. So, we take 1 by infinity as 0, not exactly 0 actually, it will be approaching 0. So, what will be S infinity? 1 by 6 into 1 by 4 minus, this is approaching 0, almost 0. Then the answer is 1 by 24, 1 by 6 into 1 by 4, 1 by 24. That means sum of this infinite series will be approaching this number. So, we write sum as 1 by 24. Alright. Next question. If sigma r square plus 3r plus 3 into r plus 1 factorial, where r varies from 1 to n, is equal to 2020 into factorial 2020 minus 4, find n. All of you must be aware of factorial notation. N is a positive integer, then this is called n factorial. We can also write it as this, both are same, and its value is n into n minus 1 into n minus 2 into and so on till 1. This is about factorial. And one more point is, if you multiply n factorial by the next factor n plus 1, then if you multiply this by n plus 1, you have factors from n plus 1 to 1 continuously. So, that will be n plus 1 factorial. Similarly, you can write n factorial as, if you separate n, you can write as n into n minus 1 factorial. Okay. Now, let us start solving this question. Given question is sigma r square plus 3r plus 3 into r plus 1 factorial. I will write like this, r varies from 1 to n. This is given as 2020 into factorial 2020 minus 4. Alright. Now, we have to express this as a difference of two terms. For any sequence other than AP, GP and AGP, the only method is method of differences, telescoping series. So, we need to express this rth term as a difference of two terms. Okay. And see, we have the formula n plus 1 into n factorial is n plus 1 factorial. So, I will try to get r plus 2 here, so that r plus 2 into r plus 1 factorial becomes r plus 2 factorial. Alright. How to get r plus 2 terms here? By adding r and 1. By adding r here and 1 here, it becomes r square plus 4r plus 4, which is r plus 2 whole square. So, I will write this as r plus 2 whole square. For making this r plus 2 whole square, I have added r and 1 now. So, we have to subtract it. Minus of r plus 1 into r plus 1 factorial. Alright. R varies from 1 to n. Now, multiplying r plus 1 factorial inside, r plus 2 whole square into r plus 1 factorial minus r plus 1 into r plus 1 factorial. Alright. R varies from 0 to 1 to n. Now, r plus 1 factorial into r plus 2 will be r plus 2 factorial. But here r plus 2 whole square is there, so 1 r plus 2 will be remaining. Another r plus 2 into r plus 1 factorial will be r plus 2 factorial. Minus this term as it is, we cannot simplify it. R varies from 1 to n. Now, if you observe, this is exactly in the form of ur minus 1. If you assume that this is ur, this will be ur minus 1. Replacing r by r minus 1 here, you are getting this. Now, we can expand the telescoping series. Putting r is equal to 1. What is the value? 3 into 3 factorial minus 2 into 2 factorial, first term, plus putting r is equal to 2. This becomes 4 into 4 factorial minus this becomes 3 into 3 factorial. Next term, putting r is equal to 3, 5 into 5 factorial minus 4 into 4 factorial and so on. Finally, putting r is equal to n, you will get n plus 2 into n plus 2 factorial, this one, minus n plus 1 into n plus 1 factorial. This is nth term. Now, this is clearly telescoping series. Cancel the terms. 3 into 3 factorial cancels, 4 into 4 factorial cancels, 5 into 5 factorial cancels. In this way, in the last term, n plus 1 into n plus 1 factorial cancels. Only second part of the first term and first part of the last term are remaining. So, the sum is n plus 2 into n plus 2 factorial minus, what is this, 2 into 2 factorial. 2 factorial is 2 into 1, 2. So, this is 2 into 2 only, that is 4. But the sum is given as 20, 20 into 20, 20 factorial. So, n plus 2 should be 20, 20. N plus 2 is equal to 20, 20. So, the value of n is 2018. Alright. Let us proceed to the next question. Evaluate the sum. Sigma r varies from 1 to n. R by 1 plus r square plus r power 4. We should try to express it as the difference of two terms. As it is, you cannot get any clue how to write numerator as a difference, because if you want to split it into two terms, we have to express numerator as a difference. Then by separating denominator, you should get ur minus 1. Alright. So, you will not get any clue for writing numerator. We can get that clue from the denominator only. If you factorize the denominator, if you can factorize the denominator and check the difference between the factors of denominator. If it is numerator, we can make it a telescoping series. So, how to factorize denominator? If you add r square, this becomes a perfect square. 1 plus 2r square plus r power 4 will be 1 plus r square whole square. So, I will add r square and subtract r square. Adding r square, it becomes 1 plus r square whole square, perfect square, and subtract r square. Now you can factorize this denominator. A square minus b square is a plus b into a minus b now. So, sigma r by 1 plus r square plus r into 1 plus r square minus r varies from 1 to n. Okay. Now you will get the clue. If you observe the difference of the factors of denominator, this minus this is 2r, we have r. So, what we will do? We will multiply numerator by 2 and here by 2. Now, we can write this 2r as difference of these two factors. It is equal to half into sigma r varies from 1 to n, this minus this. I will write it in decreasing order of powers, r square plus r plus 1 minus of r square minus r plus 1. This is 2r only, divided by r square plus r plus 1 into r square minus r plus 1. Alright. Now, separate the denominator, you will get half into sigma r varies from 1 to n. This by this is 1 by r square minus r plus 1 minus this by this is 1 by r square plus r plus 1. Now, we got a difference, but are they in the form of ur minus 1 or ur minus 1 minus ur? Take the larger term as ur. Okay. In this, if you replace r by r minus 1, you must get this. Let us check. If you replace r by r minus 1 whole square plus r minus 1 plus 1, you are getting r square minus 2r plus 1 plus r minus 1 plus 1, 1 cancels, r cancels, it is nothing but this. So, if this is ur minus 1. So, it is perfect. Now, we get the telescoping series. Now, I will put r is equal to 1, 2, 3 and so on till n and get Sn. Half is common, half into putting r is equal to 1, what will get? 1 by 1 minus 1 plus 1, 1 minus putting r is equal to 1 in the second part, 1 by 3. 1 minus 1 by 3 plus putting r is equal to 2 in the first term, you will get 1 by 3, putting r is equal to 2, yes, minus there you will get 1 by 7, minus 1 by 7 plus you will get 1 by 7 minus 1 by 13 and so on. Finally, you should put r is equal to n. Putting r is equal to n, you will get 1 by n square minus n plus 1 minus 1 by n square plus n plus 1. Alright, the same series. Taking r is equal to n, we get the last term. Now, this is a telescoping series. 1 by 3 cancels, 1 by 7 cancels, 1 by 13 till first part of the nth term. So, what is the sum? Half into 1 minus 1 by n square plus n plus 1. Alright. Take LCM and simplify. You will get n square plus n by 2 into n square plus n plus 1. Alright. So, this is the sum of the n terms of the series. Let us move to next question. It's a question in trigonometry. Already we have solved, we have completed trigonometry up to transformations, trigonometric equations even. We have already solved this model. It is a series of cosines in which angles are in arithmetic progression. To find the sum of any trigonometric series, the only method is telescoping series. We have to express every term as a difference of two terms and make it a telescoping series. For making it telescoping series, I gave you one formula in trigonometry, if you remember. We have to multiply and divide by 2 sine d by 2. What is d? Common difference of the angles. Here, common difference of the angles is 2 degrees, 1, 3, 5 and so on. That is AP with common difference 2. So, multiply and divide by 2 sine d by 2 means 2 sine 1 degree. Multiply by 2 sine 1 degree and divide by 2 sine 1 degree. Write this sum as it is: cos 1 degree plus cos 3 degrees plus cos 5 degrees and so on, cos 99 degrees. Alright. Now, taking 2 sine 1 inside, we will apply transformations and make it a telescoping series. 1 by 2 sine 1 degree into 2 sine 1 cos 1. No need to apply any transformations. 2 sine theta cos theta is sine 2 theta. So, it is sine 2 degrees plus 2 sine 1 cos 3. 2 cos A sin B is sin A plus B minus sin A minus B. Taking 3 degrees as A, 1 degree as B, you will get sin A plus B, 3 plus 1, 4 degrees minus sin A minus B, sin 2 degrees. This is second term. Similarly, third term, 2 sin 1 cos 5. Again 2 cos A sin B formula, sin A plus B minus sin A minus B, you will get sin 6 degrees minus sin 4 degrees and so on. Last term, 2 sin 1 cos 99 degrees. It will be cos A plus B, sorry, sin A plus B. A plus B is 99 plus 1, 100 degrees. Sin 100 degrees minus sin 98 degrees. This is nothing but telescoping series. What happens? Sin 2 cancels, sin 4 cancels, sin 6 cancels, sin 98 cancels. Only one term is remaining here. That is sin 100 degrees. Sin 100 degrees by 2 sin 1 is the answer. Similarly, for finding the sum of a series of sines in which angles are in AP, we follow the same method. But we have to multiply and divide by 2 sin d by 2 only, not 2 cos d by 2. Alright. Next question. Find the sum tan theta plus 2 tan 2 theta plus 2 square tan 2 square theta and so on n terms. This is also trigonometric series. Method is telescoping series. But how to express every term as a difference, that is the question. Here the angles are in GP. When a series is given in tan, angles will be in GP. We have to use one formula in trigonometry, that is, you know that 2 cot 2 theta is equal to cot theta minus tan theta. This is a very important formula in trigonometry. From this formula, we can write tan theta as cot theta minus 2 cot theta, 2 cot 2 theta. Using that formula, we will write every term as a difference of 2 terms. First, if the sum is Sn, Sn is equal to, first term is cot theta minus 2 cot 2 theta plus, how to get the second term? Replace theta by 2 theta you will get it like this. Then multiply both sides by 2. Then you will get 2 here, 2 here, 2 square here. So, second term is 2 cot 2 theta minus 2 square cot 2 square theta. Alright. Similarly, replacing theta by 2 square theta and multiplying both sides by 2 square, you will get the value of the third term. It will be 2 square cot 2 square theta minus 2 cube cot 2 cube theta, and so on. Last term, if you want last term, in the formula you replace theta by 2 power n minus 1 theta and multiply both sides by 2 power n minus 1. Then you will get last term as 2 power n minus 1 cot 2 power n minus 1 theta minus 2 power n cot 2 power n theta, which is clearly a telescoping series. Then 2 cot 2 theta cancels, 2 square cot 2 square theta cancels. Similarly, up to first part of the last term, all are cancelled out. Then the sum of the series is Sn is equal to cot theta minus 2 power n cot 2 power n theta. So, this is the sum of the series. In this way, in any trigonometric series, we have to find, we can find the sum of the series only by telescoping series. Alright. Now, today's class is completed, and tomorrow in the next class, we are going to discuss some more problems in telescoping series. This is very, very important and useful for IIT JEE. Alright. Thank you very much for watching. See you in the next class.